만나서 반갑습니다.
Thank you. Nice to meet you all.
한국자산관리공사
I am Hyeok Kim from KAMCO. So this is the order of my presentation. So I am going to briefly talk to you about the AI technology being used at KAMCO. First, I would like to introduce KAMCO. KAMCO is a public institution established under the Act on the Establishment of Korea Asset Management Corporation. And we are mandated to support financially suffering households and also to help normalize corporate businesses. And we are generating significant revenues of more than 2 trillion won a year. And we have, under our management, 750,000 parcels of general property, and we also conduct a census on administrative property on in a 5-year cycle. Now, let me talk about the new technology applications. First is chatbot. KAMCO has people on rotational assignments because we don't want someone staying in a single team and developing inappropriate relationships of bribery with potential clients, which is why we want to have people moving from department to department, and they have to learn new skills and acquire new knowledge to conduct their tasks, which is why we wanted to introduce the chatbot in order to support their task performance. And we developed the chatbot from year 2024 to 2025. And you can see that here we have RAG database. It's a retrieval augmented generation feature. So we are not using LLM to immediately generate responses. There is a RAG DB, which has a lot of legislative information and rules sitting in the database. And based on that data, information will be retrieved and responses will be generated for the inquiries that are submitted. So we have a training database which is used to train the AI chatbot. And we have trained the chatbot based on past dialogues and inquiries and responses. So let me show you a short video. So chatbot is now on the screen, and here is the prompt. For example, if someone inputs a question on the query box, then the response will be generated by the chatbot. So once the question is submitted, the responses come, but not just the responses, but on the right side, the references. For example, the relevant regulation and laws will be popping up on the right column. So the user can actually click those to go into the regulations to validate the responses of the AI chatbot. We have about 650 users using the AI chatbot, and on an average, 75 queries are submitted per day, and we have estimated the labor cost savings of 1.4 billion Korean won that will be accumulated cost saving of the next 5 years. This is based on 15 minutes being saved per information retrieval task. But there are limitations because the tables, for example, cannot be processed by the AI engine to learn from that, or if there are images that are not accompanied by a description of text, it's very difficult to train AI chatbot on that sort of data. So that's an issue that we need to get around. And we have our segregated private network, and we're not connected directly to the internet. directly. So whenever there is a Supreme Court's decision or regulatory amendments that need to be updated to our database, this was a cumbersome process where we would have to get the information from the Supreme Court, for example. But sometimes we would like to actually access this information very quickly, but there is National Intelligence Service regulations that hinder us from accessing information right away. Now, we generally do land surveys. We used to do land surveys by visiting the place or had aerial surveys. And we have about 100 people who are responsible for doing property surveys. And so it's very difficult for those few people to take care of 720,000 parcels of land that need to be surveyed. So we want to use technology to make this more efficient. Most often, properties stay pretty much the same. There's not much change. So we could maybe detect properties that have undergone certain changes using AI and focus our human resources to visit only those few properties where actual changes have taken place. So we are trying to develop this system, and our aim is to train the system on 500,000 pairs of training data, and we want to achieve a detection accuracy of about 90%. And we want to be able to quickly survey the properties across Korea and have detection completed within 90 days for all of the parcels that are under our mandate. Now, you can see this is what was drawn by people, and if people would point to where the changes have taken place. Then based on those comparative training data, the AI engine will be trained, and we would also augment this data by flipping data. So ultimately, we used 1 million pairs of data to train the AI to be able to detect changes. So Model 1 is specialized in detecting changes in buildings, and Model 2 is Model 3 is when the actual land has undergone some changes on the land surface. So using these models, the changes will be detected. So for example, if there was a land that used to be a farmland, but a building was put on top of it, these models will be able to detect that change so that people can just focus on those properties where changes have taken place to do the accurate survey. These are how we are training the AI using different inputs. So can we play the video, please? Because this is what we did to do change detection at the POC, a proof of concept phase. So here is a video.
보시면 여기 건물이
So you can see a new building has popped up, but you need to focus that the change of light or change of cars that are parked will not be detected by the AI. AI is trained enough so that it can only pick out new building additions on the plot of land. And you can see here the AI was able to detect where deforestation has taken place or land use has changed. And of course, there are seasonal changes, but AI will not detect that as a property use change. It's just going to be accurately focusing on the change of use of the land. So our accuracy is about 87% right now, but Actually, in a previous test, our accuracy was about 87%, but we have run reiterations, and we are able to achieve more than 90% accuracy now. And we expect our workload to be reduced down to about 80%. So we actually ran the AI on the 720K parcels, and we found that only a few number of parcels actually undergone significant change that requires people to visit. So it would be very effective in enhancing our efficiency and achieving a workload reduction of 80%. And when we're doing surveys, sometimes there are false detections, or sometimes there are false negatives, because if the AI does not detect a change, then we will not be sending a human person to go to conduct a proper survey. So this would significantly have impact on our survey performance. Sometimes there are false positives where the AI thought a change had taken place and the surveyor has gone onto the site and found no significant change. So in either case, there are certain limitations when it comes to the AI detection performance. So when the surveyor goes out and finds out that that was a false positive, then we would have that surveyor provide feedback, which will then be used to improve the performance of the AI engine. Currently, we are using this on the general property under KAMCO management, but going forward, we want to use this AI change detection capability on the so-called administrative property surveys that we have. And let me talk about the new technology that we are trying to develop. Well, currently our chatbot is only being used within our organization, but we want to actually open access to the chatbot to the general public so that people can actually use the chatbot to get questions answered. So we have the National Property Civil Service chatbot that we want to launch, and also we have the on-bid chatbot. So when a state-owned property is put up on sale, oftentimes citizens expect the prices to be lower than the general market price. And they submit applications to purchase that plot of land owned by the government. But then the appraisal process takes a couple of months, and when the appraisal price comes out to be higher than their expectations, they would often withdraw their applications to purchase. So we are working on using AI appraisal functionality going forward so that we could provide a preliminary AI-supported estimate of the valuation of the land so that people can submit their application for purchase on an informed basis. And so we are going to test this out going forward once it's fully developed. And now we're also reviewing the possibility of using AI to suggest possible land use design. So the AI could propose a land use design for potential buyers so that the buyers, prospective buyers, can have an idea of what they can get out of the investment, potential parking lot capacity, or how many floors the building could potentially have once the plot is sold for a construction. That sort of thing can be preliminarily designed by the AI. That's the idea we have going forward to develop. And in US, there is a service called Zillow. And based on the AI-based appraisal, the buyers can actually buy property and also get loans from the bank. So we are learning from the Zillow case in order to develop our AI appraisal capability. Now, Maxar, you probably know. Can we have the video played, please?
관리 영역이
Currently, we are doing a lot of aerial surveys. And Maxar is a case that we learn from.
네, 뭐 여기는 인공위성을
So they use satellite images. And they provide satellite images on a 7-day cycle. And we are reviewing this Maxar service to understand what potential there is of using AI satellite images to replace the aerial surveys, which tend to be quite costly. Now, this is another best practice that we are reviewing. GIS is often an area that requires significant expertise, but if we could utilize GIS alongside a generative AI engine like the ChatGPT, then we feel that we can actually improve our performance. So, for example, a staff could just type in, please point out areas that can potentially be flooded in the next storm season. Then this engine could potentially draw that out for the person without a GIS expert coding everything and engineering everything. And one of the key challenges that we have is the shortage of GPUs available on the market. And another significant issue is the huge power consumption of the AI servers, because we not only have systems that serve our staffs, but we have systems that are actually addressing the needs of the general public. We have 4 servers, and each server consumes huge amount of power, and especially when these systems are operating to detect changes of land use, it's a very power consuming process. So we are working with the KAMCO, which is the Korean power company, to overcome this issue. But when you're contemplating introducing such systems, you need to be mindful of the power consumption demand. And also, when we develop new systems, we start out one day, and then the project oftentimes takes a year or even longer. So by the time the project is completed, that technology is already not new. And so we, instead of putting out a huge project as one single project, we often do this in cascades, so that we can contract vendors at different stages of the project on a cascade basis to address the need to stay recent with the latest technologies.